Hello, this lesson is to help you with lesson 6-3. The essential question throughout the lesson is, what are logarithms and how are they evaluated? You start with a critique and reason about earthquakes. In this problem, if you're working with your companion, you'll notice that in the table in the companion, 5,500 says 4,500. It should say 5,500. So be aware of that. You can play with the calculator, you can use your previous understanding, but in this critique and reason, you're evaluating the difference between Chen and Taylor. As you move into example 1, they're looking first at a linear equation where 2x equals 8 and kind of discussing how you would solve that using the inverse operation. With 2 raised to the x power equals 8, it's an exponential equation, and so we have to use a different strategy, and that is where our logarithm comes in. So when we're thinking about this, the inverse of an exponential is called a logarithm. Right here, if you're taking notes, make sure that this one gets written down. It's a little bit clearer later in the section, but if you want to pause the video, when we're in exponential form, we have b raised to the x power equals y. When we're in logarithmic form, we have log base b, and that's how I always say it, and I would recommend that you say it, log base 3, log base 4, log base 10, but the base is always that little subscript written right after the word log. The y is called the argument, you can see that there, and then that's going to equal x. Now notice that this x and this x, our b is our base, and our argument becomes what the exponential equals. So 3 raised to the 4th power is 3 times 3 times 3 times 3, which is 81. If we're asking ourselves, like, 3 to what power gave us 81, we could use the logarithm. Log base 3 of 81 equals 4. So the exponent is 4. At this point in the lesson, they do give you this slide, and I don't love it, and so I prefer just this definition. When you move into the try it, you'll be looking at going between those two forms. In example 2, you're converting between exponential and logarithmic forms. And so we still see that 3 raised to the 4th power equals 81, and that go between. When you have log base 10 of 1,000 equals 3, we're saying, okay, 10 to the 3rd power is 1,000. So this is, again, our exponent. And we can work forwards or backwards here. There's our try it. And so in example 3, now they're asking you to rewrite. And so they're giving you log base 5 of 125. And so we're asked to think, 5 to what power gives you 125? And this one is fairly common, so we know, like, hey, that's 5 times 5 times 5, which would be 3 5s being multiplied together, so 3. In example B, we have a base of 1/4. And so we're saying, okay, 1/4 to what power would give me 16? And so we have to, this one is a hard one because of the negative symbol. And so 1/4 raised to the -2 power would give us 16. Finally, these last two examples, we think, okay, so 3 to what power would give me 0? Well, can anything to any power, like, can a number to any power give you 0? No, so this is when we have an undefined situation. My favorite kind of problems are like D. We can overthink them tremendously, but we're thinking, okay, log base 2 of 2 raised to the 8th power. So, like, 2 to what power gives us 2 to the 8th power? Well, If we think about it too hard, it's very difficult. But if we just think, okay, 2 to what power gives us 2 to the 8th power? Then 2 to what power gives us 2 to the 8th power? So that question mark must be 8. There's your try it. Now, a common logarithm is log base 10 of x, where the 10 is implied. So you would see log base 10 there, but the 10 is implied. When you see a natural logarithm, this is the ln of x, and that's where our base is e. So kind of keep that in mind, that those are two different situations, and so we don't usually see that ln base e of x, we see ln of x. In example 4, they're going to kind of go through and evaluate the common logs and the natural logarithms. And so we have log base 10 would give us the argument of 900. So we're like, okay, log of 900, so 10 raised to what power would give us 900? And so we think, we're like, okay, well, 10 squared is 100, and 10 to the 3rd power is 1,000. We are closer to 1,000, and so when we do that and we get 2.9542, that makes sense. In example B, we're thinking, okay, so the natural logarithm, base e, so e to what power would give us the argument of e to the 1st? Well, that must be a 1 there. All right, I'll continue this in the next video. We'll keep these kind of short, so hopefully that was helpful. Let me know if you have questions.